Good morning, everybody. Good morning, Gennaro. How are you? I see you well this morning. Let's start with our works. Today, we have the third session that is about the topic application of artificial intelligence in agricultural machinery and components. The chairman is my friend and colleague, Professor Paolo Gai from the University of Torino, and the rapporteur that I thank very much is XXXIV, a Palizzi Prize winner. The intervention are three. The first is by George Appic, the EU vision of AI and its role in agricultural automation. George Appic, together with Alessio Bolognesi of Federer-Unacom, are the two authors. The second one is Embedded AI for Application in Real Time by Professor Marco Bertogna of the University of Modena. And after the coffee break that we will have at 5 to 10, the third and last intervention speech about the use of AI for productivity and safety in agricultural machinery by Daniele Parazza of the Kiwitron. Then we have the discussion and key sentence drawing up. I remember that you can download from the website of the Club of Bologna the forms to fill, not only with your observation about the session, but also for your proposal that I would like to have in a big quantity about the future of the activities of the Club of Bologna. Then we have some relation, especially by Giuseppe Gavioli, about the study group activities, an intervention of Professor Graus Grön Sorensen of the SIGR, and then we close the session with the program of the activities for the next year. So I leave the floor to Paolo. Paolo, thank you very much.
So thank you, President. Dear colleagues, good morning. We'll start this session which is dedicated to the application of AI in agriculture. This is a very big topic, you know. We decided to have this session because it's a hot topic in this year. It's a disruptive technology. We are entering in a revolution, okay? So it's not an easy task to talk about that because it's a very wide and very discussed topic, but we will try to do all the best. We have 4 colleagues that will have presentation, and we try to build a path from the beginning to the end, from some theory to the application, in order to try to give some answer at the question that nowadays all of us are trying to solve. I will have just 3 slides just to introduce this topic. And the first question is, what is AI? It's a very basic question, but it is not so easy. It seems some sort of trivial question, a very easy question, but it's not at all. And so I asked directly to ChatGPT what is artificial intelligence, and I obtained an answer, which is fair. I mean, it's a good question. There is obviously ChatGPT place it at the first position, understand natural language, okay, obviously, but in some part. But there are some topics that are also of interest for us, because we are interested not particular in large language models or other aspect like this one, but in application for the engineering of the AI. So even in the description given by ChatGPT, there are some topics that could be and are of our interest. So, which is the potential of AI? One of the potential, I mean, I just wrote here an example of potential of AI, but that I think it's very important and make the difference with previous approaches in computer science, is that it's a very good tool to work in unstructured and uncertain environment, like agriculture, like in the field, where we have many elements of differentiation. The second question is, what is AI system? But the same question, but not for ChatGPT, obviously, but is the answer that man, natural intelligence, try to give to this question. So the first answer is given by AI Act. So we are talking, it's not a new topic, artificial intelligence. I mean, my master thesis was on neural networks. So, you know, I'm not so young. There are many years passed. But some sort of formal definition have been given very recently. I mean, 1 year ago, and this is the AI Act, you know, in June 2024, at point 12. That means that in the AI Act is not the first point. I mean, even in the AI Act, I wonder that what is AI was the first point, no, the 12th point. But there is. A key characteristic of AI system is the capability to infer. Infer is the keywords that describe the AI. And the second sentence in AI Act about that is the capability to infer. It refers to the process of obtaining the output from inputs and data. So you have data, you learn in somehow. So you do not have an explicit rule, but you learn from data, and then you build some machine, some system that can generate output on the basis of this experience. In parallel with the definition is again May 2024. It's very similar because he infers from the input he receives to generate outputs. But it's rather complicated because if you think that we have already many methods we developed many years ago that uses this concept. I have some data, obtain some parameters, and then I react, I build my algorithm using this parameter. Bayesian methods are in this field, for example. Many image processing methods that use that compute the thresholds using previous data are in this field. So everything is AI is the question. So this definition looks forward, but in some sense we have also to look backwards, because maybe some ancient old methods, classic method, could be represented by that. So it's complicated. It's not just a question, a matter of fact, but it's very essential, because what happens in what is written in AI Act, the new rules apply to AI methods. So maybe we have a method we are using since 10 years, 20 years, and nowadays it's AI, and nowadays should respect new rules. So it's more complicated. There is another sentence which is important, but it's just the starting point of the discussion of today. Not every inference qualifies as artificial intelligence, so they understand that there is a problem. Here we have a problem, and the solution is only this system that can adapt dynamically with the changing of the system. So it's some sort of continuous learning, continuous adapting. This is a possible solution to the question I posed, but it's just the start of this topic. We have to discuss this morning about that. I would like to revert the normal process. So, sorry, President, I have to change the order of, but I would like to start from the questions, and then I will pose you some questions, and during this morning we will find together possible answer to this question. So it's on the contrary, that in the final discussion we will talk about this question. You can also propose others, but this question were the first we consider preparing this work. So our objective, mine and of my colleagues, is to try to give some elements to find answers to that. Some questions here are very difficult, so it will be not possible to have an answer after this morning, but it's just to start a discussion with the colleagues. Okay? That's all. So I leave, this is the program. Actually, we have 4 different talks. So the first 2 are based by 2 colleagues, but are separated. But we built all the program of the morning together. So I hope that this will work as best as possible. So have a good session, and I'll now introduce the first speaker. which is the professor Georg Happig from the University of, let me say, because in the Institute of Technology of Braunschweig. No, this is he studied at the Institute of Technology in Braunschweig in mechanical engineering. Then he has a PhD he joined the Institute of Agricultural Machine and Fluid Technology at TABS, led the Team Assistance System in Cooperative Machinery, and earned his doctoral degree in automation and loading of silage crop in February 2012. In 2011, he joined ACHCO, Fendt, as a software engineer focusing on isobus automation. After leading the EE system engineer team 2014 to August 2020, he served as the solution architect for all premium tractor platform in ACHCO. Nowadays, Georg is a full professor on agricultural robotics at the University of Applied Science in Kempten, Germany. So thank you, Georg, to accept to participate to this section and to be here. So the stage is yours.
Yeah, thank you, Paolo. I was wondering a bit on how to start such a topic on a Sunday morning when everybody need to be tired. The true fact is I wanted to ask ChatGPT and I didn't make it. But I learned some things during my studies. At such a situation, you can either do a silly joke so everybody wakes up, or you can do some clever speaks about engineering and such, or you care about kids. And I'd like to start with kids to give you some first view on what I think we should have in mind when it comes to AI, that understanding how it works is fairly natural, although it sounds artificial. I'd like to give you an example in technical design for AI. If you think about riding a bicycle, and as mentioned, this is a bit polemic anyhow, what does an engineer normally do when designing a system that can do bicycle riding? I'm a mechanical engineer in my background, and normally we do model forces, model inertia, we measure velocities, we measure accelerations, and we try to understand the complete system that we defined. We define equations to calculate on them, we calculate the forces, we define stability criteria, all over to have a system that is running. But in the end, with such a system on board, what do we have? We have a system that is perfectly understood in a given environment, but what happens if this environment changes? And now I think most of you say like, well, I didn't learn bicycle riding like that. I didn't teach my kids bicycle riding like that. And this is more the AI portion. Because when we do that, what I did with my kids, what you did with your kids, first of all, there's a parent view. There's not only an engineering view, although we all like the engineering view. The parent view is fairly easy. Parents explain how bicycle riding works, and parents show how bicycle riding works. This is the context. They help and adjust the system to do bicycle riding. This is what we do as parents. And in the end, at least this is what I did, and I'm pretty sure that all of you did, we trusted the system that at a specific point in time, it will do, and it will work. Because the kid itself, it tried, it failed, it improved, and in the end, this is what learning is about. And this is, for me, the starter that nobody shall be afraid of AI. Because from the basic, it's very natural and very easy to keep in mind, although it's not deterministic, and although from a classical engineering perspective, this is definitely a new thing. Paolo said this is an evolution, and this is what I like to show a bit. So, what I will talk today about is, first of all, looking a bit backwards into what has been the evolutional steps in agriculture and engineering and how AI interferes with that. Not interferes. Some examples of use, because it's not that it's completely nowhere. There are already systems in use. And then given a bit the bridge towards Alessio's presentation, coming from the constraints, explicitly from data constraints, towards his portion, caring about the regulatory that need to be fulfilled for going with AI in the European Union. So, looking about the evolution, I think you all know better than I do. At the very start, in agriculture, there was this first mechanization. We built tractors, we built machines, and we allowed the classical agronomists to use more force and more torque. This was the first step. Then it came to an automation step where we see that specific particular work could be repeated and repeated all over again. With this sort of automation, we were able to increase repetition and to increase the rate of specific work that happened. So this is just a next step. Then a third step came, what I said, it's digitization. We all know that it's still ongoing, but looking 20 years back, there was the first stage when it came to computers, when it came to ECUs being placed in the machines, and beyond automation, now we're able to be even more precise, to be more predictable, and to have a better controllability. Now these were steps. I tend to say that AI is not another step, it's an evolution, and as mentioned before, AI might be the one game changer to change the paradigm of all the steps that had been already taken. So it's not just a new one, it's a reflective one that allows for better handling of what we already have in the field and in place. This said, artificial intelligence and machine learning, and don't make the difference today, for me is definitely, it's an evolution of engineering where we have the ability to rethink all the paradigms that we have ever thought of. Now, it's not a future topic. As mentioned before, there are already something in mind. I will hurry a bit because we are already late. We have multiple domains where AI already is used in agricultural and agricultural engineering, crops, livestock, post-harvest, and definitely management systems. Looking at the crops, we have weeding where AI is used, spraying, autonomous navigation is coming on the board. In livestock, definitely when it comes to welfare, when it comes to health monitoring, these are aspects where AI already is in use. When it comes to post-harvesting, and we heard it yesterday, post-harvesting explicitly in fruits is something that is of relevance. There, camera recognition, image recognition is already in place, mostly based on AI systems when it comes to sorting and grading. And in management perspective, what agronomists normally need to do as well, yield forecast, decision support systems, they are already trying to integrate AI, and they will foster that path. Now looking a bit into specific examples, and as mentioned, I do it a bit quicker as planned. Three examples are what I have today. Two of them are very similar. When we look at a precision weeding robot, and looking about ag robotics, this is my nomination, this is my background, this is something obvious that AI is in use. There is a problem, which is kind of normal. In traditional weeding, either we have extremely high labor cost and it's labor intensive if we do it manually, or second path, we can use chemicals, which from a sustainability perspective is not only the preferred one. The solution is fairly easy. A robot is covering the field autonomously, detects plants and or weeds. This is something, there is an ambiguity in what to detect, either the good ones or the bad ones, and then acts precisely. This means in detail that we have a camera detection, we have an AI model to detect those plants, either weeds or the useful plants. Useful plants is a bad word anyhow, and then have the precise action. So looking back in what I said before, the precise action is something that we already have. As mentioned, this can be an evolution, not just a next step for new applications. Benefits are clearly simple. We have a reduction in chemical usage, sustainability is on the path, and we have automation of work. Labor shortage is something that has been addressed yesterday already, and this definitely is one answer. There are limitations. I'll skip that because I'm going into the limitations anyhow. Light and soil condition, everything what interferes with the image recognition is a problem or a challenge. Smart spraying as a second example, I'd like to have chosen this due to the fact that smart spraying doesn't need any new machines. We can use classical single nozzle control system that we already have in the field, detect single plants, and then fight against them. The way is simple, or it's similar to what the weeding robot does. We have some intelligence that detects plants or weeds, and then there is a single nodal activation to fight those plants. The setup, and this is what I really dig into, in general, I tend to say we can use classical given machinery, and this is, as mentioned, it's not new. It's an adaptation. It's the next step in this class of machines. Limitation, as mentioned before, I go to that later. Livestock monitoring, for me, one of the most visible examples, because there we always say in arable land we have this high variability. I tend to say, at least for me as an engineer, I do understand machines better than animals, honestly. So for me, this is always super complex. It's needed. Health changes are subtle, and we need early detection. And what AI now is doing, and deterministic systems are doing quite similar, they track movement, they track activity, they track vocalization of animal and husbandry. They care about body conditions and detect behavioral anomalies. How does it look like? It's not that all the pigs are looking this nice. This is a classic identification and clustering of different behavior of cattle. This is pigs. These are pigs in a barn, and this is ongoing. This is running. What we do and what we earn is an early detection of diseases, and we all know what happens when diseases are spreading. This is something that no one of us really want, not only from an economical perspective, as well from an ethical perspective. We know that there are some problems going on. We increase animal welfare at low costs. And here, explicitly, there are restrictions that I do not concern later on, so this is why I highlight them. The device robustness in such an environment is definitely challenging. There is technical complexity, and this is another portion. This is technology, and conservative farmers normally are not easy to accept this out of sketch. So there is as well a socio-ethical aspect of AI in the use. So looking about challenges and restrictions, now I needed to, Hans-Jürgen, one of your tractors, and I'd like to ask the question, why, if it's all done, why don't we see those machines running in the field all the time? Because there are still challenges and restrictions. There is plant behavior and different stages of the plants that need to be consolidated. There are weather conditions which make it extremely hard to detect, to reliably detect something in the field, and explicitly from our processes we interfere with the field. So we allow dust. It's not that we allow dust, we do dust. This is what happens in arable land anyhow. And this will interfere, at least when it comes to camera and every optical system that is in use. There are two other constraints besides the variability, and this is hardware. And I think Marco will tell us a bit about it. Hardware costs for AI systems normally are either not as robust as classical embedded systems or just super expensive, and this is something that we need to overcome anyhow. You will tell us that it's not super expensive, I hope so. Good. Another point is, looking at the farmers, explainability and trust. And I think this is definitely key that we as the classical engineers we are the ones which has been trusted for years. So we will be the ones to explain that even those non-deterministic systems can be trusted to a given extent. But before doing that, we need to understand what it's about. Looking a bit into engineering, and these are only 2 slides coming. I do see that there is an explicit paradigm shift comparing classical engineering and AI-based engineering. Classical engineering, really going through the development process, in the model and design, so the very first stage in classical engineering, we define rules, we define the good behavior of a system, and we model the system as such. When it comes to AI and learning systems, we do not only define some systematic behavior, it's more that we need to define the context. Looking back at bicycle riding, we do not explain any kid how the forces on the pedals are, but we explain how it should work in the system of the environment where the kid is riding its bicycle. So it's a completely different approach in engineering that we need to foster. Second, when it comes to VV, validation, verification, generally spoken, we can verify by formulas. So either a formula is matched or not, and then you fail or you pass. Here in AI systems, validation is done on statistics. So it's not a black-white decision that comes out. It's either somehow yes or somehow no, but it's not black-white. Third, when we come to adaptations, our classical behavior is, okay, we know the system very well because we designed it, so we know how to adopt it based on requirements. In this AI system, there is a paradigm shift because we do not explicitly know how the model works. So what we need to do is we adapt the system behavior by different data. We do change the environment that the kid is using for bicycle riding. We set it on snow, and then it works on snow, some when, right? When it comes to the optimization of control, it's fairly the same. Manual tuning of parameters, that is what we are used to out there in the field, having more or less stable controllers, stable rule sets, and we need to adopt that so that they are broadly used. When it comes to AI systems, this is the same pattern, but we train it automatically. So it's not what we control the different parameters by our behavior. They are trained automatically, and we need to care about the context that is learned. Last one, the interpretation of malfunction, and this is a super interesting one because as of today, failures are based on the model that we design. In AI systems, these failures doesn't exist. It's more like that there are biases and there are data gaps, and these increase the probability of a malfunction or a different behavior than expected. Now, in sum up, classical engineering, what do? We define a specific behavior of our system, and we guarantee correctness. When it comes to AI systems, we design learning conditions, and on a verification perspective, we quantify confidence. So we are never deterministically 100% sure how the system reacts, but we can use statistics. We all know math, and statistics is a key to overcome the situation and to make it somehow trustable. Coming to Alessio's speech, there is one key, and this is data, because in the end, the AI model is something, as I mentioned, we do not really get it anyhow. But we need to care about the data that we use for learning, and there are some problems. Now look at let's say the happy path, how it should be done on a farmer perspective, because this is the data that we need for learning systems. We have sensor data placed somewhere in our processes. We have manufacturers carrying this data. Is it Echo, is it John Deere, is it Kubota? It doesn't mind at that point. It's somehow stored on machines and then progressed towards platforms, to FMIS systems, towards any hub that is consuming and using data. And then it's shifted to the farmers. Now it sounds great, but the reality is that at least between these two portions, between manufacturers and platforms and manufacturers, there are some ambiguities that need to be considered. Because data ownership is, in most cases, either non-constructive or not clear. So we have machine data, we have farm data, and they are all owned by someone, but that someone doesn't help to have an overall consistent data set. We have data acceptance. This is something that is as well on the, let's say, B2B business, because there is a really hard reluctance to share. I had several years in Fendt, and I know that we never share data with John Deere, just as an example, nor with some others, but that's another fact. There are fears and dependencies explicitly when looking into farmers' eyes. They really fear being dependent on specific providers. This is something that we need to reconsider as well. Data quality is another aspect. We have rare annotations, we have different annotations of data, we have training data that is completely different, although they are for the same purpose. Biases, data sets, and context-sensitive data. So we have data, but it's not annotated so that we can use it for a specific context. This is something that needs to be overcome as well. And we have data fragmentation due to a lack of standards, and I don't mean ISOBUS, because this is a really, let's say, easy standard when it comes to annotation and labeling of data. This is completely new. There isn't any standard on that. There are some primitives due to tools, but there ain't no standard at all. Presence of dialects is something that need to be considered, because a sheep isn't a sheep, isn't a sheep, isn't a sheep, and yellow isn't yellow, isn't yellow. This is something that need to be considered as well. And interoperability is something that needs to be addressed. And with this, I'll definitely like to now invite Alessio to his speech, because he will care about these points that I'd identified where we have ambiguities can be addressed by policies, at least to a given extent. Thank you.
Thank you, Georg, for your presentation. The question and discussion is the end, so we continue directly with the next presentation, which is introduced by Alessio Bolognesi. I will introduce Alessio Bolognesi, which is an electronical engineer graduated at the University of Ferrara, Italy. He has a long time background as an ISOBUS system engineer, which brought him to work in CNH as a responsible for his ISOBUS architecture for medium tractors. Nowadays, Alessio works in Federer-Unacoma since 2013. He is the responsible for digital agricultural affairs, following EU regulation, international standardization activities, and event relation to innovation. Thank you, Alessio, for being here. The stage is yours.
Thank you, Professor Guy. Thank you, Professor Happich. And you already introduced some of the challenges I'm talking about today, because we have a lot of brand new opportunities for our industry, even if Europe looks like so much putting together some difficult regulation to be implemented by the industry. And of course, the main purpose of those regulations is to guarantee an ethical and safe use of the technology, which is good. But in the end, the burdens and the duties for manufacturers and players in the agri-food chain in general are pretty high. And I try to frame a little bit the environment in which we are moving today, starting from the two main regulations which are impacting products using artificial intelligence that will be put on the market, or like Professor Guy mentioned, which are already on the market due to the broad approach to the AI by the Artificial Intelligence Act, which is the main regulation we are talking about today, even if, of course, our machinery have to deal with the machinery regulation. So these two are the main ones in general for our product in our industry. And I'm not talking about tractors, which follows a slightly different path. But in the end, the Artificial Intelligence Act is born to set rules for the development, deployment, and use of artificial intelligence in order to ensure safety, transparency, and ethical use of artificial intelligence in the industry, and to provide services to the user. But in the end, there are several problems from an industry perspective in this European regulation, which is the one that Professor Guy mentioned. The AI definition is way too broad. It includes basically everything. And then there's a classification of AI system based on the risk. So we have to deal with this high-risk definition, which will face in the future very high restriction in terms of third-party certification. But we dig deeper into that later on. And another thing is that industry has to set up a whole management throughout the life cycle of a product to deal with the artificial intelligence problems that will arise in the future. On the other hand, the machinery regulation, we all know it's replacing the machinery directive and basically sets the safety requirements of all basically the products we are putting on the market as an industry, independently if it is an agricultural machine or a component. But there's a paradigm shift in this regulation, which used to be dedicated to hardware, I would say, product. Because now the machine regulation introduced the safety component which includes the definition of software as well, including AI. So software is part of a safety component of the risk assessments and so on. In case of the high-risk machines, so where the AI is used and the safety component of the machines is developed with an approach for a self-evolving behavior, whatever it means, which is totally unclear at the moment, then the manufacturer have to undergo to a third-party assessment, which is a problem, and then I'm going to explain you why. But these two are the main regulations for us, or all of our industry, I would say. But on the background, there are a couple of more, much more than two, but these are the other ones that I would highlight today, which are the Cyber Resilience Act, which is setting the requirements for digital products put on the European market in order to ensure a better protection against the cyber attacks throughout the whole life cycle of those products. Basically, the aim of this regulation is to improve the safety of the persons more than the product by protecting the data. We are still investigating on the impact on our industry, on the manufacturers, but the clear idea is that the impact is really huge. Because we have to put on the market products which are safe by design, and we have to deal with all known vulnerabilities when we put the product on the market. We have to know everything about the vulnerability of our products and similar products which already had some problems in the past. In the end, we have to guarantee that the product will be protected against the attacks even in its entire life cycle. And that's actually not easy. And also, Professor Happing mentioned data as at the base of training AI models. But then we have the Data Act, which sets the rules about who can access data and how, and sets the rules for the industry to data sharing, to the use of services based on data, and so on. We provide machines to the farmers, and in the end, the final users have a lot of advantages from these regulations, because even I can switch services with my mobile phone from a provider to the other, and the providers have to guarantee that the data can be ported from one service to the other flawlessly. But from an industry perspective, it is a huge impact, because we have to deal with this portability of data and implement it somehow. Of course, standardization is part of this approach. Then, I mentioned the more or less, I try to frame what we have to deal with, but I'm go back to the definition of artificial intelligence in Article 6 of Artificial Intelligence Act. Or better, I'm going to deal with the high-risk definition, which says that AI system is high-risk if I'm going to read because, I'm sorry, don't remember word by word. It is a safety component of a regulated product, regulated by another regulation, which is the main one for the product. And the product, based on its main regulation, is required to undergo to a third-party conformity assessment. Basically, that means that everything from autonomous navigation system, and I said here some example, automated pesticide dosing or spraying, because they can impact the health of people. Safety critical self-evolving decision support system that can influence the human behavior, maybe how we deal with animal, for example, hazardous materials, and so on. And the point is that it's not just a technical problems for the manufacturers and the industry, it's also the process and the management that they have to set up to deal with those regulations. Documented risk and vulnerability management system, data quality and traceability of the data used to train AI models, human oversight if needed, and so on and so forth. And I mentioned here also post-market monitoring because nobody is ready at the moment, I believe, to provide support to their customers about AI systems, or very few of us, I would say. In the end, this new legislative framework is an headache in many areas. First, because we have to deal, like I mentioned, with machines that can self-evolve, whatever it means in the future, or when they are put on the market and they are in use. We have this, I would say, battle between homologation and self-certification. We are used to have homologated products for tractors, for example, or no-road mobile machinery as well, but then we have the self-certification of products, CE marking, which is based usually for all the implements and such a kind of machines. Then an autonomous machine is a tractor, is a machine, is whatever. We still don't know. We have to clarify that, and we're working very hard on that. And in the end, I hope that already was highlighted a little bit in the introduction of the legislation. We have an overlap of regulations. AI Act is overlapping with the Machinery Regulation, which is overlapping with the Cyber Resilience Act, because Machinery Regulation has also cybersecurity requirements. The Data Act basically is playing along with this regulation because they are all the technologies today are based on data, and so on and so forth. I try to highlight a couple of problems we have. The first one is the, like I mentioned, this overlap between AI Act and Machinery Regulation. And I believe the main problem is the conformity rules. We already said you have a product which is high risk for the Machinery Regulation, if you follow under the Machinery Regulation. So, it is self-evolving, and then it requires third-party certification. So it's also high risk in the sense of Artificial Intelligence Act. But then the assessment and the conformity of these products has to follow two different paths, which are similar, but not exactly the same. And possibly they have to undergo to a third party by different notified bodies. And this is a huge problem for the industry. There's a responsibility confusion. If we have AI on our machines, on our safety components, is the responsible the manufacturer? Is it the software or data provider maybe? I just put software, maybe data as well can have some role in that. And of course, machine regulation, even in the new shape, is dealing with the conformity assessment in a fixed way. So you put a machine on the market, you say it is safe, and that's okay. You are guaranteeing for that. But if it is self-evolving, how can you guarantee that after 2 months of use in the field will be still safe? This has to be figured out. We are not at that point today. And of course, we have a point related to the data that are used to train and validate the AI model. So basically, we have different problems coming from, arising from this overlapping. And in the end, Europe said that it's implementing some guidance and some standard to deal with those problems. But we are way too late, even because the timeline of this standardization initiatives is not in line with the timeline of this regulation. So we are coming late with these standards. Another point, which is, well, it's not unclear, is just, again, a change in the way we have to approach the design processes, which is the safety versus security aspect, which is different because since today, up to today, we were used to separate those things. We have the safety of the product and we had maybe the cybersecurity of our systems or services. Now we have to guarantee that the product, which is maybe a safety component which is put on the market, is secured by default by the CRA, and this security means that it should be safe, because the attack, a breach in the security can drive to a safety issue. And this is, I would say, completely new, or almost completely new for our industry. So this is, of course, implying a lot of new challenges from a technical engineering perspective, and from our manufacturer's perspective, it means that for the first time, their security and safety teams have to work really strictly together. Just a hint that as a Federunacom, like many of our other players, are working hardly with the European Association, SEMA, towards the European Commission to get clarity, to get guidance, and so on, to approach these new regulations. It's a hard job because we have to deal with other very, very strong industries, but it's a work we have to deal with every day. We said that AI models, and I'm going towards the conclusion of my presentation, AI models are based on data. And this data are really important because today, I would say mostly in our agricultural sector, the data are really fragmented. We have data from different machines, from different brands, different services, different sensors. Each one is using different data models. This is not what we need to train AI models. We need data that are, I would say, interoperable. This is the word that we say every day in our life nowadays. And AI depends on the availability of a large, consistent, and high-quality annotated data to train those models. But I would also say that our industry is in a pretty good shape, or at least we started earlier than other ones. We learned maybe since the 90s, I would say early 2000, from this experience made with the ISOBUS standard, the ISO 11783, because we approached the standardization of data between tractors and implements dozens of years ago. So we have some experience, and of course we set up this Agricultural Industry Electronic Foundation that provided the certification approach for ISOBUS implement, guaranteeing the compatibility. But then we are moving forward because it's not just machines, it's a cloud system, it's services, platforms. So, for example, we founded this Agricultural Interoperability Network initiative, which is kind of trusted and safe peer-to-peer communication between platforms and systems from different providers and OEMs, which is a piece of the puzzle of the interoperability of data. But then we need standard data, which are compatible from a system to another. There's another initiative, which is the Gateway Adapt, which is, again, a standardized data model, which is continuously under development to standardize those information. In the end, it's also a worldwide felt problem. So in the International Standardization Organization, we set up a new technical committee, which is the 347, which is not a case data-driven agri-food system, and basically is doing that. It's trying to find the gaps in the standardization for data models and data transfer between machine services, etc., and try to fill those gaps. Everything is coordinated by this ISO Smart Farming Coordinating Committees, which is basically where everything is under control and follow the path of these standardization initiatives. So the goal basically is to have interoperability of data coming from all the players in the agri-food chain and not just in the farms. Just to mention some initiatives that can be useful for standardizing data, for standardizing safety approaches, for standardizing the conformance to some of the European regulation. I mentioned the ISO 11783, but the functional safety standard for agricultural machinery, for example, which is going to be reviewed and including, for example, software parts related to the AI systems or use of AI systems in safety products. We are developing the 24882, which in our aim will be providing presumption on conformity to the Cyber Resilience Act and Machine Regulation, and so on and so forth. I don't want to bother you. But like I mentioned, we have many regulations, and it's really hard to implement standards to give presumption of conformity to all of those, even because in certain areas like AI, it's totally unclear what we should standardize. Just to conclude, I skip the summary just to mention that I believe that AI, that like it or not, will be part of our future. I don't know how far the self-evolving machines will be in our future, but certainly from a certain point in time, we will be facing this problem in an actual way. Of course, the number of regulations I expect will be increasing, not just in Europe, but even in other parts of the world, because initiatives are ongoing even in Australia, Japan, and so on, but also opens up a lot of new opportunities for new products in our industry and in others. And I believe that we're going to see some examples of those new opportunities catched by the following speakers and companies. Thank you for the attention. Professor Guy, up to you.
Thank you for your presentation. With this presentation, we had a complete framework of the rules, and nowadays rules that are still in the phase of final definition. So also the complete scenario is not done. So this is why it's particularly difficult for manufacturers in this moment to move towards products to put on the market. Then with the next two talk, we move to the application. That means to the technical implementation of AI, and with several examples. And I'm very glad to introduce the first speaker, which is Marco Bertogna. Marco is a full professor at the University of Modena and Reggio Emilia anymore, and leader of HYPERT Lab. This main research interest in high-performance real-time system, autonomous driving, and industrial automation system. In 2008, he received a PhD in computer science from the Scuola Superiore Sant'Anna di Pisa. He has authored more than 100 papers, receiving multiple Best Paper Award in first-level international conferences. He coordinated EU and industrial projects, securing them more than 20 million in funding for his research group. He is CEO and founder of the academic spin-off HYPERT and co-founder of Minerva System. Please, Marco, the stage is yours.
Thank you, Paolo. Thank you for inviting me. In this talk, more than going very technical, I will try to explain a little bit what are the main challenges in the problems that you guys already heard in the first two speeches. You probably noticed that doing real AI on practical stuff, especially for agricultural machinery, but in general for any other machinery, it's extremely difficult. One thing is a demo, one thing is a prototype, one thing is a show, another thing is doing massively scaling products in this domain. On the other way around, we know that this market is changing very rapidly. It's incredibly changing. I was just checking right now the market value of one of the first players we have been working with, NVIDIA. We have been working with NVIDIA since like 12 years ago, when NVIDIA was not known to the main public. If I had invested 10K in NVIDIA back then, today I would have like 3 million. Well, I did invest, and I did suggest to invest on NVIDIA, the problem I sold to buy a house, you know. The current value of NVIDIA is $4.5 trillion, which is more than the overall market, capital market of the main stock exchanges in Europe. This tells you a lot, okay? We can talk a lot, but this tells you how the domain is shifting. Is it good? Is it fair? I don't know, probably not, but this is what is happening. And it is something that could have been foreseen 12 years ago. At least we, in our very, very small community, we foresaw that target. The target that moves towards embedded AI, so the AI that becomes physical, that becomes sufficiently safe to move stuff, to move vehicle around. I'm a professor. I experienced a lot the distance from the academy and industry. We have been talking yesterday at dinner a lot about that. I think what is needed today is this close distances between academy and industry if we want Europe to have a good answer on that. But let me go back on that. Why now? So why can we do physical AI, embedded AI, just now and not 10 years ago? This is a slide I keep using since years, which tells you very, very simply why. So Moore's law scaling, number of transistors integrated to the same chip is constantly doubling exponentially. So now you have in a square centimeter the same computing capability that you had in the larger supercomputer in the world just 15 years earlier, okay? That's true numbers. The domain controller we use in our autonomous vehicle today, like they consume 10 watts and have the equivalent computing power of Deep Blue or whatever supercomputer you have back in 2010. So is this computing capability at reduced cost size and power that allows you to power up those deep neural networks and controller that today we can put inside our vehicle. Here there are a few images. You will not find in these slides many technical details, just like video and images. Just to give concrete example that this is possible, this can be done. You can see here the first vehicle we automatized 13 years ago. It started with a trunk full of clusters of computers, and then it moved to an embedded computing systems that was consuming just 20 watts. And more than targeting the automotive domain, which for a number of reasons is not so easy to be automatized, despite what Elon Musk may say, we decided to go more on a reduced operational design domain, like agriculture and logistics mainly. These are the two domains that we mostly wanted to target. Wanted to target not only as a university always falls short. We also funded a company grew. We are quite consistent in growing up and trying to do like a technological reference, at least to the Italian or European ecosystem. All this trend toward autonomous driving, when did it started? Maybe some of you recalls back in 2004, 2005, the first challenges of autonomous driving funded by DARPA. DARPA is the defense organization in the US that was powering millions to universities around the world to challenge them to be able to drive cars or trucks or whatever in not so difficult environments. Back then, those trucks were running at 20 kph, 30 kph, and so on. And from there, all the major engineers behind the main companies in the autonomous driving domain popped up, like Google, from like Waymo, the control company by Google, Uber, Tesla, and all the companies that you now know. 8 of them are companies that were not existing in 2000 and now are valuable among the 10 most market capitalized company in the world. Just to tell you this domain shift, which is consistently continuing. Tesla is also probably what every one of you knows. Tesla claims to have autonomous driving since 2013. Next year will be coming, next year will be coming, next year will be coming. We don't yet have an autonomous Tesla. Autonomous means with no driver, okay? With a safety driver you can, it's a level 2 plus, level 3, but you cannot safely afford to drive a Tesla with no driver. The only one that I would afford driving with no driver is by Google, is Waymo. I will touch later this point. But doing autonomous driving is, again, is incredibly difficult. It's very easy to do a demo. It's incredibly difficult to do products. This is the amount of investment. This is not a new slide. It's again another slide I keep using. That was 5 years ago, but the trend continued, even worsened. These are the initial investment by competitor of ours that just to start are given $1 billion to start. These are names you probably don't even know, okay? Half of them already failed and bankrupt, okay? And look at the flags there. Look at where they are based. It's China, China, US, US, China, US, China. There is not a single one in Italy, not a single one in Europe, okay? Is it true, good, bad? You name it, we can discuss after the break, but this is the situation. Are they stupid? Are they, I don't know, too risky? I don't know. The point is, they're not still making revenue. They're not making revenue. Most of them are not yet safe to drive. This is urban driving, okay? This is urban autonomous car, but very, very similar trends are happening in logistics, agriculture, and so on. One example is Cruise. Cruise Automation was a company smaller than our company that was bought by General Motors in 2013, 14, 15, I don't recall well, for $1 billion. Since then, GM invested 12, 13 billion dollars on that, and last year or 2 years ago, they declared the end of the autonomous driving division, okay? So it's a very, very risky task, moving everything towards ADAS, Advanced Driving Assistance Systems. Even what you see that drives autonomously often requires some remote assistance and remote driving control, okay? This is also something that we are heavily working. So it's not completely autonomous. Maybe it's 99.9%, but it's often a good idea to make your autopilot a little bit more conservative and be able to intervene remotely in a safe way. Again, I'm reiterating how safety is very, very much important here. This is the only car I would enter nowadays. If you have been to Las Vegas or to San Francisco, you probably stumble upon one of these cars by Waymo, by Google, and these, I would say, they are safe. They are incredibly safe, but the investment were incredibly high. Google powered more than $15 billion on this project. The car has on board something like 52 sensors, like 13 cameras, 4 LiDAR, 6 radars, blah, 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 blah. You can imagine the cost, okay? Would you do that for a tractor? Would you do that for a lawnmower? Would you do that for, I don't know, your cutlery machine and so on? Of course not. Then it would cost way more than what would you gain. The alternative is instead what tier ones are doing, at least in Europe. So they are doing the bottom-up approach, so evolving the driving assistance systems, which is also something that seems to be very smart, but also ends up increasing very much the costs of this, let's say, driving assistance kit. You can see how now one of these mandatory kits costs more than $6,000 in a car that, you know, the single dollar counts in automotive. So this is an incredibly high price for something that is not even yet partly autonomous. Okay? These are the money at stakes. So what we believe and what we are striving and trying to do is to marry both affordable and safe autonomous driving kits, not for urban, not for streets, but for reduced domain, starting from the simpler part, going industrially, merging and working together with the companies. We don't do steel, we just do code. And it's not us, I don't want to promote us. It's just the way I think that Europe could do without this billion-dollar investment, because there is no hope that we can reach that amount of investment, which in the US are given by mainly venture capital. There are incredible amount of money there. Just with a fancy presentation and a few background coming from MIT, you can raise very, very easily a lot of money. China, our competitor, we are 80, they are 2,000. okay? Is state-owned, state-subsidized company, very nice company, very good company, but again, there is a state subsidizing that you probably know. What does it take to do an autonomous driving kit? Of course, if I were a customer, I wouldn't be willing to pay more than what human labor costs, okay? So this gives you a target, okay? There are social aspects, there are many, many other parts that I will not have time to touch upon. But Europe should start reasoning about what kind of investment and synergy and open innovation approaches we can do, because the world is definitely moving there. It's just a matter on when it will be sufficiently safe, like the previous presentation properly said. This is just a summary, so I don't have time to go very much into technical details, but this is just a glimpse of what it takes to do an autonomous driving system commercially. Of course, there is the steel, there is the electronics, there is the sensors, the eyes, there is the real-time operating systems, there is the communication middleware, localization, multi-sensory, typically to be resilient. You are willing to use cameras, radar, LiDARs, laser scanner, GPS, and so on. Perception for detection, tracking, geolocalization, classification, prediction, forecasting, planning globally and locally, control, even model predictive controller, mapping. If you can map, you should map. This is not Tesla's approach, this is Google's approach. It's better to map when you're running always in the same environment. It's more safe, it's more predictable. Signal processing, sensor fusion, trying to understand pros and cons of each kind of sensor. You need to have expert on radar, on camera, on data, on Kalman filter, on fusing all this kind of signal, and a little bit bigger, the human interface. You're probably very familiar on how complex interfaces are not commercially viable, okay? So you need to hide this kind of complexity behind the very, very, very simple handle for the final customer to be tuned. And besides that, this is just the technical part running online into your architecture. You need a lot of other instruments, what we call MLOps, DevOps, AIOps, all this kind of software that you need to tune, to train, to collect data set, to label them, to simulate. We do a lot in simulation. I will tell you, I will show you later some simulators that we created and use in order to test your architecture in virtual scenario before moving to the real ones. And having simulator with a limited sim-to-real gap is definitely something you need if you are willing to commercialize at scale your kind of autonomous driving system. Then data management, again, connecting well with the previous presentation. These machines become very nice collectors of data. Think about what you can do with all this data that you can collect on fields in agricultural domains, zootechnic, and so on. And over-the-air update. This is not something that you sell and you don't update. You are very, very likely to need to update this kind of systems very often, okay? And think about safety, certification, and so on, how this collapses, like Alexio said, with over-the-air update capability. By the way, Tesla, you have an update every now and then, every few months, there is an over-the-air update, okay? So these differences in the automotive domain and the machine directives domain will be questioned in the near future. So, yeah, we did many other things, but let's now, after being pessimistic, doing the more optimistical part. So, Europe is winning the challenges today about the main challenges in autonomous driving. The DARPA challenges today are masked as racing challenges. So we removed even the speed, the speed limits out of this autonomous challenge. I'm not talking about Formula Student. These are higher challenges organized in the US, Emirates, Japan, and so on, with real cars, Indy cars, racing cars. This is an example of us and our friends from Munich battling each other at very, very high speed. 280 kph we reached a few months ago in overtaking scenario. This just to tell you, we don't know what the other vehicle would do, we don't know anything, it's not remotely controlled, these are completely autonomous, just based on the sensor they have on board and one embedded computing architecture they have on board. It's incredibly difficult to do that, believe me. So there are many nice things that can go wrong. The cost of each car is huge, so any accident costs you a lot. And everything needs to be done in real time. Just to give you an idea, what we did, this is 2 months ago in Monza. Think about maybe as a first-person view, the amount of data they should process and react in real time within a few milliseconds in order to do the next control action. In GPS-denied setting, GPS is not stable at all in this speed and in this scenario. And this is the thing that in Europe, still, there are many nice groups that are able, there are few very nice groups that are able to do this kind of capabilities. Is this enough? Not at all. This is not a product, okay? This is the technological ecosystem that Europe still has. I'm mentioning our group, the group in Milan, the group in Munich. We are always first, second, third, second, first, on front of MIT, Berkeley, Caltech, KAIST, and so on. So there is still hope, provided that industry tries to join, and academy moves a little bit closer to industry. This is in Abu Dhabi, so today 15 of our guys are there to, let's say, compete in the next challenge. Feel free to look for A2RL, so it will be, the challenge will be showing in mid-November. The prize is $2.5 million, and again, universities all around the world will be competing for whoever will be able to win these autonomous racing events. And again, our hope is that from there, the European ecosystem, like the US one did in the past, will be able to at least showcase and attract some interest in industrial companies. I will not touch upon what kind of agricultural application can be done, because I guess Georg already covered that pretty well, so I will not reiterate on that. Just maybe showing some example of what we did. This is a simple, not even so known Italian trench that we equipped with our, let's say, domain control in order to do like very simple and cost-effective solution that can even fit in a vehicle that costs 10K. So not the Google approach, and that is able to run even when GPS is not working. So behind solar panel, photovoltaics, trees, many other different kind of, let's say, obstacles. Simulation before testing. It's, again, it is very important to have nice simulator where you can like keep running and simulate hundreds and hundreds of different scenarios before you go to the real deployment. We are not Tesla. We don't have thousands and thousands of vehicles around, okay? So simulation for us and for Europe, I guess, is probably the way to go, and then you will need to finely tune when you go in deployment. There are many other robots that I will not have time to show you that we are experimenting. It's not steel, so steel is not the value. It's not so difficult to do this kind of robots. It's not easy, but it's not the main problem. But you can do like many different kind of robots. This is just to give you a little bit of imagination for what can be done in the future. This is a 4-track robot that we equipped with a robotic arm, and think about what we will be able to do with robotic arms in the future. This is an application we did for industrial robotics that just with a single camera today and neural networks, you are able to detect even in a cluttered environment like a specific object in the 6D positioning, something that in the past you needed very complex interferometer, lasers, and so on. Now you can do with just a very basic, simple camera. So think about the picking and other kind of operation that in agriculture you will likely be able to do in the future. So reaching conclusions. Again, I don't think value will be in the iron, in the steel, but like in many other domains that you already saw, this value is moving towards algorithm, towards code, not general algorithm, but being able to be deployed at a scale. Anyone can build a robot. Very few can make it operate safely. Safety and AI. Safety and AI, whoever solves this problem will become the next NVIDIA here. Hardware enables autonomy, software creates autonomy. There are very few groups, technological champions that are able to collect that kind of resources, reaching a real products for for you guys, for industries, and for the European markets. It's not a work you can do with 5 or 6 people. It's not a university project. It's way more difficult than that. But there are many, many nice opportunities. All these investments are there to testify the potential interest, then who knows what will happen in the future. Software have faster development cycle, over-the-air update, the ability to remotely operate, the value of data, the data flywheel. The more data you have, the better you train, the more customer you can reach. The first mover may have a competitive advantage there. There are very fast improvements. I keep telling my guys that the software we have today in 3 years will be completely different. It's incredibly fast. We even have difficulties in attending every conference that we are trying to do that, but it's evolving significantly faster. Edge computing and AI today already enables your decision making, but do not underestimate what it takes moving from a demo to a real product. Take-home message. So we need to find a way to get Europe competitive, not saying Italy, but saying Europe here. With just one single country, we don't know anywhere. We don't go anywhere. I told you that UK, France, and Germany together, their stock market is valued less than just NVIDIA. Okay? This tells you how small we are. So either we get together and do something, or we are doomed to be eaten by someone else, okay? And the moment is now. So I believe we have a very, very good technological ecosystem. We have very, very good industry. We should just win a little bit this fear of investing, and investing smartly, not like powering money around to academy at random. This wouldn't even work, okay? I don't have a final solution, just telling you the problems, then someone else will maybe provide solutions. You need open innovation. This, to me, is probably the best way to go. So industry that bets on academy, that bets on spin-off, that bets on technological champions. And the market is huge. The market is really huge. Every single market I mentioned before, logistics, agriculture, defense, material handling, port logistics, every single market there is huge, is really huge. Competitors are not yet there. Name me one autonomous agriculture, not GPS guidance, really autonomous agriculture that you know. There are very, very few, if not any. Okay, so there is still time, but clock is ticking. So like Mario Draghi says, let's do something. Thank you very much.
Thank you, Marco, for your very interesting talk. We made a jump in the future. So now we have to come back because we are late. But before the coffee break, we will have the official photo in front of the building, or here with the table. Okay, here. And then
Yes.
the coffee break.
We have to take 3 photos. One here, the other outside, and the third one with the landscape of Bari there. Okay. And then finally we have our coffee. So please, in front of on the table. Also the invited speaker. Everybody.
we will. It's not our. So. This is another question. Just a moment. You have an USB. This is Type-C. I don't know because it's not a, this is as an Apple one. Yeah. Apple is a word apart, you know, is a completely another word.
You know about Apple. You can
So, do you know, do you use Apple? Okay, this is better that you use an Apple man because
yeah.
we have to copy the presentation somewhere. Okay, it's quite similar.
Sorry, which one? Yes.
Yeah.
Which is yours? CIJ? This one?
Yeah. Oh, it's quite similar. Yes, a little bit.
But now I need your help. What's the copy? Copia, right?
Yes, copy there.
Yeah.
And then
Let's paste. No paste? Desktop is
this is a question of Apple computer.
but
You know.
usually it's
First
can
of
you
all,
see paste here? Is that paste? Somewhere paste? No?
or if you want to try with Control V,
No, but it's we go here.
make Control C and Control. Okay.
That's easier.
Okay. Are you able to create a folder? This is the owner of the owner. Who is? This is okay. Club of Bologna now has another computer.
She's got another computer.
No, please. So, let me.
You know where it is.
Anyway, I suppose that the owner arrived.
Yes. But it's also here. If you go, that's yours. Good luck. It's only 10 minutes, right? It's a nice closure.
Please take our place to start again and go towards the conclusion. Please, because we have lunch about at noon and then the transfer to the hotel. Perché no? Sì, non so se... Professor Paolo Gai and Daniele Parazza. Buongiorno Daniele. Please take our place and follow with the work of the meeting. The third session sees like speaker the third speech. Daniele Parazza, the use of AI for productivity and safety in agricultural machinery.
So Daniele, I'm glad to introduce Daniele Parazza, which is the co-founder and the Chief Technology Officer of Kiwitron, a company specializing in safety assistance solution to industrial and agricultural machinery. With a solid background in electronics, telecommunication, and IoT system, he has built his career in the intersection of embedded technology, cloud computing, and artificial intelligence. So please, Daniele, the stage is yours.
Thank you. Nice to meet you, everybody. My name is Daniele. As Professor Guy anticipated, I speak for Kiwitron, which is an Italian company which was born around safety goals. Safety, it's a broad concept, so we wanted to try a real market approach for everybody in all fields to enhance the safety in the workplace, but also with an eye to productivity and to prevent loss of efficiencies. Kiwitron is a relatively young company because we founded it in 2019, and since then we started with a small group of engineers working around new technologies. I am one of the three founders, and the three of us are all technical backgrounded people. So we really love technology. We love to study new technologies and emerging technologies. And the goal is always to find practical uses of those new technologies in the real life, specifically in work life. As of today, we are around 90 people working on developing and producing safety solutions based on technology. Our technology spaces from more traditional radar, radio systems, vision systems, and of course, AI systems. Today, I'm going to share with you a couple of applications, but I'm going to be really quick on that. I don't want to stay too much time on that because we already saw a lot of examples of applications of new technologies, specifically AI technologies, in the agricultural and farm field. So I'm going to focus more on how you, as OEMs, as workers, can use the technology and how companies like Kiwitron can help you do it without too much effort and with the right balance between costs and benefits. So, inside the machine, you have a lot of components. Each of that component has a specific task to do, specific job to complete, and usually we can divide those type of tasks between a safety task or a productivity and efficiency task. So either a component must do the job, or a component is there to enhance the safety, to prevent risks from happening for the worker and for the machine itself. This is just an example of a safety system applied to a tractor. You can see there are two vision sensors, two camera sensors, which of course are edge AI sensor that monitors the area behind the truck, in front of the truck, sorry. So the whole area, 180 degrees in front of the tractor, it's covered by this vision sensor, and then there is a light for the people surrounding the truck with also a sounding alarm. The aim of such system is to prevent the truck, the tractor, to find itself in dangerous situation for people around the tractor. So, more easily said, the system detects the presence of people and warns the driver inside the cabin of the presence in dangerous spots of people. The system is based on AI machine vision, so it's able to detect people regardless of its pose, of its position around the tractor as soon as it's inside the protection area. Inside the cabin, we have an HMI panel, a display panel, which shows the live video feed from the systems. This is particularly helpful where there is poor visibility, so it can help as a traditional backup camera. But it's there to prove, to show how the system is working. In this specific case, this was a tractor made for a test case. And then there is an LED interface also for the operator on the right side. The round thingy shows really quickly, really intuitively to the operator the protected area and whether there's a danger at which level. So the lights can turn from green to yellow to red. This is what the system sees. So you can see that a person is detected with a red box around it. And the system also has a stereoscopic vision sensor, which gives the whole system the information about the distance of where the person detected is located. So with the distance information, we can trigger different intervention levels about warning the driver or interacting with the machine itself. So this is just an example. Speaking about a different type of application, so the other group of components, we already saw a lot of applications, so I'm not going to go deep into that, but we made some work with crop line detections for precision weeding, and also the other example is for plant mapping. So the difference between these two examples is the crop line is an active system, so it actively helps the work by positioning the equipment based on what the sensor is detecting. The other system is a passive system because it's only used to map data from the field. So we can imagine a tractor and equipment has a vision sensor, a camera sensor installed with this type of system while it's working on the field doing its things. The system collects the information about, I don't know, health of the plants, presence or not of the plants, if there's some plant missing, and then can update the information stored on the database system. So this is similar to the example of what Marco said before, it's mapping data. So if you are there on the field doing your job, why don't collect data? And data, it's the most important thing, because all these advanced technology systems work with data, are trained with data, but can also provide and collect and generate new data, which comes directly from the application, and it's specific to the application. Data is important. I would say it's a must to work on data, not only for the specific task of the AI component, but also for all the decisions that come later. This is an example of some safety-related data about dangerous situation that happened on the field. So that's an analysis of a month of work of a tractor with a system installed. And this is a report about all these safety, potentially safety issues. So it's important to know how many times the tractor worked, and inside that period of time, how many near misses happened. Because this is important to understand how dangerous it's the machine and how dangerous it's the work that it's doing. Based on that, you can make decisions about changing the environment, maybe scheduling different operation in different times to prevent the occurring of these safety issues. Again, let's do a quick step back. We talked a lot about AI, but AI really isn't so different from traditional algorithms. The main difference is how it's built. So traditional software, it's built for a task. The programmer defines what is the input and what are the outputs for each input. So all situations are predefined and are known upfront. This gives us the possibility to test and to build a system in a reliable way, in a predictable way, so we know exactly how the system reacts in each and every situation. AI was defined, one of the first times AI was defined as a machine that is simulating what are the processes of natural intelligence. So it's not the specific function, it's not if you see that, do that. It's more on how a natural intelligence comes to a result given a task. So this has a lot of advantages, because you can build an AI system, can be built to perform the same task over and over again without having to know all the conditions and all the inputs up front. This has a lot of advantages in terms of application. We could simplify saying that an AI algorithm is a lot more generalizable than a specific algorithm, which its only application is defined at the time of the build. The way that AI works, I was saying, it's with data. So the algorithm, it's trained with some examples. I'm going to simplify a lot. So as the example of learning to ride a bicycle, it's the same with AI. So we are going to train an AI using some examples of outputs that we want for that specific situation, and teaching it what type of output we want. Let's imagine that we are teaching our children after a good ride on the bike. We see a dog. We are just saying, to our children that that specific animal with that shape, with that behavior, with all the information that the child can gather alone about that specific animal, we are just labeling it. We are giving it a name. We are saying, this is a dog. This is similar to the training process of AI. Of course, it's not sufficient to have just one take. We have to do it a lot. The measure of how many of this iteration we do, basically we can define it as the data set. Then once we have done this, we can put our AI model out in the field and make it to perform its task. The output of an AI model, it's not black or white, as has been said. It's statistical, it's probabilistic. So our model would be good or bad in its task based on how much precision and confidentiality we need. So the model will respond at this, seeing this image will respond. It can be a dog. It works even with data that has never seen before, of course, because this is why we use AI. We use AI because we don't have a given set of inputs, given set of situations predefined that we can put into a traditional algorithm. So in this case, the AI model, it's able to understand the situation. Our little child is able to say that this animal, it's also a dog, even if he never seen it before. The opposite side, it's not a dog because it's not black or white, but the task of the AI that we asked for is to detect the presence of dog. So if we give the AI model an input image, in this example, where there's an animal but it's not a dog, the output of the model would be it's not a dog. And then things like this happen. The model has never seen a cat which looks like a dog. We don't know which details our AI has learned to determine whether something is a dog or not. So things like this happen in real life. As an example, if you can't read, this is an example of one of our early models, which it's detecting a fire extinguisher as a person. Things like this happen in real life. And this is why it's really important to understand that building the model and testing the model in-house, it's not the complete workload. Maintaining the model and knowing how to maintain it, knowing how to measure it, how to observe it once it's in the field, it's part of the development. And I would say, from my perspective, it's the biggest part. So why does this happens? It happens because maybe our initial data set, it's not big enough. Maybe our initial data set has some biases, and so on. It's really important to know and understand deeply how the data set which made the AI model is made. Because in situations like this, you need to adjust your data set, adjust your labels, adjust the way that you teach your child to recognize dogs against cats. It's not easy. It requires, of course, experience. There are a lot of pretty standard ways to do that. But of course, it's something completely new. Maybe it's something that you are not used to deal with. And there are also regulation requirements to do so. So it's not just a technical issue. It's also a matter of being conform to all the regulations that today are out and are going to be perfectionized in the future. So, just a quick overview on AI Act. We already saw that also. So, the key reading of AI Act for you as manufacturers, for you as users, integrators, it's based on risk. You have to understand when you want to implement an AI system in your machines, you have to ask yourself which type of risks this system can have. Risk for the individuals. So AI Act defines 4 tiers of risk, starting from the bottom. Minimal or no risk are applications that, let me say, have no impact on individuals because they don't interact with them or they don't see them, like your firewall anti-spam filter. If it's based on the AI, it's a minimal risk system. Or video games and so on. Then we have a limited risk, which is one of our interest for today. Limited risk system, in example, can be chatbots, video generating systems, and so on. Informative system. So we have a system that interacts with people, whether it's through a chat interface, whether it's a video that you see on social media. This is a limited risk system. And for this specific tier of systems, AI Act has some light requirements, which can be pretty easily fulfilled. We're speaking about transparency, mostly. So what you see today, maybe on AI-generated videos, the watermark of the model, that's a requirement. And then we have high-risk system. High-risk system generally are defined as systems that may have a big negative impact on individuals. Systems that can perform social scanning on yourself while you're out in town, and so on. Also, systems that are integrated with safety, functional safety system are considered high risk, given the impact that can have on that functional safety. And then the upper tier is the prohibited systems, which of course are not allowed and cannot be used in any circumstances. So, about compliance for limited systems, limited risk systems, basically it's just a matter of informing users about what they are dealing with. It's important that they know that they are interacting with an AI system or an AI-backed system, even if a small part of what they are using it's made by AI. You have to inform them so that they know that not everything is the truth. The most common example is ChatGPT. While you are using it for researching something, you always have to ensure that what comes out of it, it's real and it's not made up. On high-risk system, there is a more strictly compliance requirement. A quality system, it's needed. A quality system which includes all the tracking about the data set that the AI system is using, specific training details, and so on. So basically, you can imagine like your company quality management system, something like that must be applied to all that is AI related. In case of high-risk system, also there's an EU database that is used to collect all the high-risk system. So that's it's like saying to the EU, hey, this system exists, comes from me, I know everything about it, so in case you want to audit it, come to me. Also, in case of the usage of AI system in functional safety machines, the AI system must be part of CE declaration. That means must be part of all the risk assessment and so on. We as Kiwitron, we want to provide nearly an out-of-the-box compliance experience to you. What we suggest is to start low, because AI, it's so cool, can do a lot of good things, but it's not that easy to understand, it's not that easy to use. So we act like an enabler. So with our solutions, we have ready to integrate hardware and software and also compliance. That's not a work that we can do alone, of course, but we try to give you the support and also a product which is ready to be compliant based on the level of risk that you want to achieve, that you need to achieve. My suggestion is to start easy. Like any new other technology, we have to gain confidence with it. We need to understand how to work it, how to integrate in every different situation. So start easy, trying to configure a low-risk system. A low-risk system can be what we saw in the first slides. So an assistance system which warns the driver about dangers around the tractor. That can be seen as a low-risk system, as long as it doesn't interact directly with the safety functionalities of the truck. So my suggestion is to start with something like that, find your use case, and compliance will come easier. We will help you with that. We already have that type of use cases proven to be compliant to all the regulations about AI Act and also Cyber Resilience Act and new radio equipment updates. And then from there you can go up. But we can't pretend to make that big gap from 0 to a high-risk level system without having any previous experience, without having a base to start from. So this is my suggestion. And also there's a consideration to be made when you speak with your customers. Because customers, they have to invest money on your machines, on your equipments, and then if they want, and if you want to offer them an AI system with better performances, you have to have a price balance between the gain that the customer has and what he has to invest. Also with the limited risk system, it's easier because the compliance is just a matter of mapping what the system does inside the machine, and that's pretty easily done. This reflects on lower cost for the end user, and this is the step that it's suggested to take if you want to start working with AI, embracing the future. Because AI is here to stay. Whether we want it or not, whether we like it or not, AI is here, and we have to find a good way to use it to give benefits to the end user and also to the market itself. So basically, that's it. If you want to know more about topics discussed here, you can find my email there. I will be around for till the end of the day. So thank you for your attention, and thank you again.
Thank you, Daniele, for your very interesting presentation, because you give us some words of hope. I mean that we made a long travel in artificial intelligence, and in the end we have some point where to start, I think also as a manufacturer, and I think that we have to start slowly, integrating components. Maybe the first application will not be a complete system. We know that this is maybe for a demo, but in order to have some system that could be on the market in a short time, it's a good solution to start integrating single components that can help in driving the machine, in using the machine, even if we have not the complete objective of having a full autonomous system. Full autonomous system is something which is our objective, but can be reached immediately, but with some steps that help us to better understand the rules, the legislation, which is improving day by day. We know that we have updates, and we are waiting for some technical specification from AI Act and other rules. But at the same time, we can start experimenting this technology also from the point of view of the farmers, because also the farmer should start adopting that and start using that and assimilate this technology. So we can start with the discussion part of this session. Can I have the computer with the slide? Sorry for that, because we switched just a minute, because we have the question. So I would like to restart from the question we proposed at the beginning, to see how we were able to try to give some elements for that. Thank you, Georg. I'm sorry for that, because everyone was here.
So I hope I didn't close it. Yeah, but the USB sticks in there. Just kidding. Just put it in, that's fine.
Okay. These were the questions I posed at the beginning, and we tried with the presentation to address this topic. As you know, it's a very hot topic at this moment, but I would like to start the discussion, so starting from this point, starting from what we have discussed before. So,
thank you, Marco. So today we have seen some interesting application of AI in the first and second presentation. And next year when we come back to Bologna, we can even see more exciting AI applications. And soon we have to deal with super intelligent AI that can potentially be used as a weapon for food, like in a Hunger Games situation. It can widen the inequality. It can dominate the food production by removing human from decision making. My question for the panel, and not only for the panel, for the entire group, is what can we do now, politically, technically, and morally, to kind of safeguard human
from super intelligent AI in future?
It's a very simple question. So,
Okay, yeah, now it's better, yeah. So, superhuman. So before superhuman, it would be interesting to be almost human, okay? So the almost human part is already sufficiently difficult, okay? So this is the part I would focus right now. Even doing like almost human is incredibly difficult to do it in a safe way. So that part, to me, requires a lot of investment that, as I probably touch in my talk, I wouldn't expect to have, not from venture capital, not from state. Okay, so the only way I see is doing open innovation, so industry together with technological champions, okay, academy, something like that. For the superhuman, well, it's very questionable. You can reach superhuman in something, okay, but I'm more pessimistic about like superhuman AI. For instance, we may gain a professional driver, beat a professional driving in racing, okay, but I would say it's way more difficult to do a car that goes autonomously everywhere, okay? So that kind of superhuman, I don't think is so likely, okay? For specific tasks, like in agriculture, I believe we can reach superhuman there. You can reach even better than that. You can augment scale at which you do stuff at limited cost and like overcoming the human labor shortage. Okay? That part is at reach, still requires a lot of investment. The only solution I can think about in Europe is merging together what remains of the big industrial companies towards this more innovative approach in an effective way. I know it's not like a real solution, but it's the only way out that I can see without waiting for bureaucracy or VC that are not existing or other stuff here. But there is hope. There is really the possibility to do that. This is at reach. So more than superhuman, do almost human together. This, I believe, is feasible. Of course.
Can I add one thing? You're totally right, but we also have to think about verticalities. Don't think about superhuman in, for example, do a machine that can do everything, right? But if we think about specific application like spraying pesticides, for example, it's impossible that a human goes leaf by leaf on a plant to check for pests, right? But actually a machine now can do that in real time and spray just where the pest is. It's not superhuman, but from some perspective, in this very special and vertical application, it is. Because it's doing something that we can't do, actually. But it's a... Well, I don't know if I have a question.
we are moving to AI ethics. I mean, it's a very big...
For instance, we are working a lot with the defense now, just defense, not attack, okay? There is a clarify that question. So you can imagine how big is the interest in this kind of technology in that domain, okay? There I'm very worried about taking human decisions, okay? In agriculture, yes, but maybe less risky. So that kind of like decision, we typically take it with the human in the loop. Just the human doesn't need to go everywhere, okay? It have a pre-screened, very limited, 1 out of 100 amount of data, just with significant data, and still keeping human in the loop. What worries me instead is more in the defense sector. Where superhuman and the pressure that you have on that environment and the financial sector that you have there, that is worrying me a lot.
And also, let me say, a machine can be only as good as the top of its capabilities that are given by humans. So if you give a robot the ability to move around this room and stop, then an AI inside can maybe self-evolve because it has given the capability to do so. But what's the main dangerous situation that can occur? Maybe It can learn how to move dangerously. It can learn how to move to hurt humans. That's the most danger that that type of machine has. So what we have to do as engineers, we have to build safeguards around that possible outcomes. Of course, I understand that the main image that we can have in our mind is a super AI that it's somewhere around ourselves, in the air, in the cloud, on servers. But the cloud environment, it's not so different than the real concrete world. So the same safeguards that we could apply to a physical robot, we can apply on the cloud. So if happens that a machine containing an AI model which decides to perform a cyber attack on some power sourcing facilities around the world, then it will be because a human misconfigured its protection. That it's something that it's happening even today, even without AI systems. So this is the danger that we have to build safeguards around.
You have a question, Andrew? And then
I have an additional, hold on, just one
sorry.
additional aspect, because maybe that sounds a bit weird, because we all are engineers at some specific point. Let's compare artificial intelligence and humans. Because in the end, if we are afraid that AI is overtaking us, what can humans do? Humans kill people. Humans hurt people. Humans are bad. So these are the rules that need to be done on AI systems as well, so that it becomes more a ethical aspect of AI and not just technology.
I completely agree. And this is a big field of research, also ethics of AI, because, but I think that AI Act which is very wide in the application, start from human studies to technological stuff and so on. The concept of risk analysis is valid for all the stuff, and this is the point. In any application to analyze which could be the consequences of the decision of the system, and then to put some limits to that. And this is true for medicine application, for agricultural engineering, production, everything, I think.
Okay.
Andrew, please.
Okay, thank you very much for this presentation and this discussion. I have the question rebounding for your presentation, Georg, right? You mentioned it, the area of application of artificial intelligence in the decision to help take the decision, and how you estimate the risk of prioritization, if I can say, of decision makers if we'll often use these tools, and lost so-called the tacit knowledge which we had acquired with his experience. So how you can comment this risk?
So that's tricky question, because I'm not able to do any answer in numbers or something like that. The risk is there, and let's phrase it easily, although it's really hard to do it that way. The risk is there, and it's on us and on the users of such systems to frame it towards the right direction. So it's not deterministic. There are some probabilities that it's done wrong. So it's on the experts to define rules so it's not used wrong. But the risk is there, unfortunately.
Please.
Well, first of all, also from my side, compliments for these excellent presentations, and also for is that better? And also for the importance, in my opinion, the importance of this subject. And we can see that the risk play a major role in developing these systems, and I fully agree to that. And this takes time, and this takes a lot of money, you see. Now my question, in my book I have made an analysis for headland automation, and I found that a tractor with front and rear implement has a sequence with about 30 actions. I could read it, but it takes so much more time. But it is 30 different actions, and we had also a PhD thesis on that, and we found that it's very complicated, but it could be done, and it's now commercially available. But according to John Deere, the sales are very, very low. And the reason is that the programming is too complicated. So my question is, what could be done to improve the handling and the acceptability of the farmer?
No, okay. Well, this, let's say, in general, HMI problem is well known, I would say, in our industry, and because it is quite newer compared to other industries which faces that problem much earlier than us. But the point is that it's from an industry perspective, we have, and the manufacturers have to work to make these products easy to use. There's no other way, I believe. It's impossible to understand, to think about a scenario in which the farmer has to learn 30 buttons, 20 screens of interface, etc. They have to go on the field, push a button, and make the machine running. This is what we need to do from a user experience perspective for our machines. Are we far from that? Yes, we are actually far from that. Even with the normal system, you mentioned the electronic systems, but I could mention the task controller, for example, which in the earlier stage, this repetitive task setup was pretty difficult. Then we learned, the industry learned from the experience and made those systems much more easier to use. And I expect AI could help in this area as well, understand which are the gaps of users in operating the machines, and maybe try to fix those gaps with the artificial intelligence. It might be an area to be investigated.
Yeah, I agree with you, Alessio. So the question is very good. Probably is the point now, okay? So it's not only HMI. HMI is the final part, okay? The point is that it is very easy, fairly easy to do a demo and to go for a specific setting. The most difficult part is to generalize, okay? So even framing what we called ODD, the operational design domain, so the set of conditions in which the OEM or the tier one or the supplier of the system assumes full responsibility of it, even framing it is very difficult, okay? So understanding how you can take 80% of your requirement, doing a systematic analysis, and doing that your software doesn't need an engineer to go there and make it functional, okay? That part is incredibly difficult. This is what it took us. We had like demo 7 years ago, and from there to doing product at scale, that's very difficult. AI can help, okay? AI can help. And then HMI is the last part, okay? Understanding of what kind of handle to give to the final user. This part, if you do it properly, again, industry and academy together, that can have a very, very significant impact.
Can I add just one thing? Sorry, education and information. This is something we have to highlight anytime, because this is where we should start from.
Yeah, I wanted to start
people.
something similar, because as of today, so I worked a lot in HMI at Fendt. As of today, the consumers, so the farmers, are used to understand explicitly what their machine is doing. Now we already learned that predictability is a bit downsized when we use AI, And this is as well some sort of education. We made some trials about adaptive teaching systems, honestly. Still, it's super hard to find customers to use it because they cannot rely explicitly on what is that outcome. This is another aspect.
Okay. This is better. It's really human interface is important here. So, but that's the trust in the system. So I could trust maybe that this automatically knows that I'm speaking and it automatically should go on. So having the trust in the system is then, I think, a key element to make it acceptable by farmers. But the thing is then, the AI takes over. Self-driving car is probably one of those examples. AI takes over, and then when something goes wrong in the field where you can talk about those herbicides, you can talk about harvesting, something goes wrong, AI has taken over. So who's responsible now? Is it the farmer that is still driving his tractor, but this machine is controlled by AI? Or is it the manufacturer? Or is it just something, well, God did it the wrong way? So how do you go about that in terms of acceptance?
Easy question. Only easy question.
Yeah, love it.
That's not easy question. But I will answer with another answer first. So, do you all trust your car while you drive it? Because, you know, modern cars have a lot of electronic system. So, we're not speaking specifically of AI, but the accelerator pedal is controlled by wires, which the electrical signals are fed into the ECU. So, how do you trust that? And also, this
is different from driving a car, because this is an operation that happens behind your back. You don't see anything of what is happening. When you're driving your car, you can still stop it. But here you cannot stop things. You don't see anything. You don't feel anything.
Yeah, I understand. I still think it's quite the same thing because, of course, the actual implements which works in the traditional way, maybe some have automation to it. You have to build trust in it. When you have it new, the first time, you constantly check how it does, how it performs, and then you build trust. I don't think it's a lot different with AI. And also, let's make a difference. AI and self-evolving systems. AI can be not self-evolving or can be. The main difference is if you build an AI without self-evolving capabilities, you can test its performance in all the different situations and build your self-trust into it. In case of self-evolving, that's a completely different story, okay? Because then you have to understand how it's changing its behavior based on what. Because again, an AI system, it's not a program that gives you output based on the input. It's an algorithm that makes assumptions, makes reasonings, and you will never know exactly how does it work. So the only thing that you can monitor, observe, it's from the outside. So manufacturers might have to specifically determine how self-evolving system self-evolve and how does it work, and provide ways for the farmer, for the end user to understand how the system is evolving. And so this is that's referred to data collection and data analysis. So the systems must be able to manage that data, that information, and present to the farmer in a usable way.
Now, if I can add a real information, what we are actually doing. Well, the industry is conscious of this problem. In the future, we have this maybe traditional with the autonomous guidance versus full autonomous tool carrier, whatever we call it, with the implements. How to deal with the safety of those systems. We're conscious that we have no solutions that so far, but we are trying to investigate distributed perception system. We are investigating ways to make safe all these scenarios. We have a solution now. We don't. The point is, maybe it's not just technical. From a technical perspective, we could have a solution. The point is also liability. Who is liable in case of an accident? And this is the real answer we have to give to the industry, to the farmers, to the maybe European Commission, etc. This is the real problem. Then all the technical stuff comes later on that, actually. But we have to solve, if something goes wrong, who is guilty? The tractor, the implement manufacturer, or whatever. So no solution at the moment, but this is an issue we well know and we try to investigate.
Yeah, just a quick update. Referring to AI Act, for those who are tired as high-risk systems, their AI Act requires human supervision. So this is, at the time being, the only solution to that situation. Of course, it's not enough, but that's what we have today.
And that's another problem. AI Act is not covering a couple of a tractor from one manufacturer and an implement from another manufacturer. This is the real problem. Again, liability.
Yeah, human supervision implies liability for the human which is supervising. So at the moment, it's the farmer.
Unfortunately, we have to move because we have the scheduling, and this afternoon there are the planes, so people have to leave here. We have just time for a short question, I think, Benno, and then we can discuss again during the lunch. So we are here, also my colleagues are here, so I'm sorry, but we do not have time. It's obviously, it's a long discussion. We have many things to discuss about that, and then, but we cannot do that. Please. We have just time for one very short.
Okay, I asked the last question. So I asked this from last two speakers so we can speed up. So you gave some examples about the training a few years ago, I mean, for these industries like recognition of humans on the picture and that kind of things, and how to use many pictures of the dogs and cats to train these models. But now when you do these commercially, these kind of systems, are you still collecting the pictures of the bales and cows and this sort of thing? So are you leveraging the open source or open weight models in your pipelines? Maybe you can answer shortly yes or no.
That's a good question. I think more time would be needed to go into that. But the answer is yes and no. Of course, you have to know the data set. So if you use public data sets, you know you have to track it, of course, because it's required by AI Act and other regulations. But then you have to understand how it's built and what's inside of it. Because there's also a lot of security issue.
But my question is that are you using the models, not the data sets?
Sorry?
Are you using the open models, not the data sets? That was my question.
Okay, about models. Models can vary depending on the applications. So we tend to select the best fitting model based on the application. So it can be an open model, can be a customized model based on an open one, can be a fully customized model built from scratch. It really depends. So there's not a one answer fits all.
For me, yes. The answer is yes. Like data are incredibly valid. The moment like you equip your machinery with like sensors and a high-performance domain controller, then it becomes a very, very interesting data collector. You know, think about Tesla. Tesla, the big amount of value it has is the data it collected. And they continually collect and collect to create digital twin, retrain out of it, doing simulation, and go back. This is called data flywheel, and it has an incredible relevance. A way more relevance than people may think, okay? So the sooner you start collecting this data in a proper way, not just doing petabytes of random data, okay? But in a correct way, has an incredible value. The 30 applications that the professor before mentioned, all these 30 applications, I don't know what they are, but for sure they require a lot of data properly collected. So this is the way to go, together with the other direction, the over-the-air update, in a safe way.
We do not have time to, so the discussion will go ahead during the lunch. I'm sorry. So I conclude this session. I would like to thank again my colleagues for their contribution, for their presentation. So thank you very much for being here.
Thank you, Paolo. Really interesting, this session. So we go to the end of this day and also this meeting. We have to speak about some topic like the study group's activity. During the management committee of Friday, we have decided to reduce to 4 the study group, but not to reduce the activity, because the study group about the dissemination and social media is more than a study group, it's our life. We want to make know the activities of the members of the Club di Bologna, itself, and so it is an internal function coordinated by Patrizia Menicucci that we thank very much, with the Professor Roberti that will be the referent of these activities, and by myself and Marco Fiala. The study group activities will be divided in 4. The first one is by Jos the Bardemaker. I'll give the floor between few minutes, Jos, to speak about another important activity involving next edition of the Club of Bologna. The second study group is coordinated by Peter Pickel, the third by Emmanuel Hugo, and the fourth, the new study group about by Giuseppe Gavioli about the relationship between the university and public research centers and agricultural machinery industry. So these are the study group. I ask to you if you want to to write, to send an email to the different coordinator if you want to participate to the activity of the study group. Also to make this study group continuously working during the year until the next edition. I give the floor to Giuseppe Gavioli, to my friend Giuseppe. Giuseppe, you have the floor, please.
Thank you, Danilo. So the new study group is about the relationship between university and industry. It's a broad theme, it's a very important one. And so we would like to define kind of models or behaviors that are particularly effective in producing outputs, results about this relationship. So we will start understanding which are all the benefits, all the possible outputs of this relationship model. And we would like also to adopt a very global approach, covering the entire world, not in detail, but all the regions of the world, because we believe there is not an automatic, simple solution. Probably there are multiple models that can work according to the different regions of the world, the different requirements, situations that may be evolving. So we'll try to have a broad perspective. The members so far that we have been started working with are myself, Stefano Fiorati from CNH, Benno Pickelmeyer from ECHO, Kesafan from TAFE, he was here yesterday, Gahendra Singh, professor in New Delhi, Andri Yatsul, professor at Uni La Salle, Ali Reza Pureza is here, University of California, Davis, and Akindele Florina Longe, who is a professor of University of Uyo in Nigeria. We'll try to have a representative of both industry and university, and representative from all over the world, because what we would like to do is to study initially a little bit the problem, try to put boundaries together, and some do not discover something that has been already done. So we'll read some literature and summarize what's already existing. But immediately after, we would like to move to data collection. We would like to generate knowledge through two actions. The first one is a survey, a questionnaire that we are putting together to be distributed to people around the world, possibly some hundreds of people in the universities, research centers, and industries, to collect their experience, to collect the data, information about what's going on in the relationship between industry and university. And we will also use some interviews for qualitative purposes, not quantitative like the survey, because from the interviews you can capture nuances and gray tones about the personal experience, significant personal experiences. Also, the Club of Bologna members will be interviewed to make sure that we cover a broad spectrum of experiences and contribution. Then, based on all this information, we will try to put together a series of recommendations or models that may work or are already working in order to give the opportunity to the Club of Bologna to provide recommendation to policy makers, to university managers, to companies, and speak up because this concentration of knowledge, this ability to collect and generate more knowledge that the club has, should be really a very important resource for a lot of players in the world. So we don't want to solve all the problems. We will not be able to capture everything about the relationship between university and industry, but we would aim to start providing the Club of Bologna some new energy to distribute knowledge around the world. So we'll find, of course, we will report to the Club of Bologna first, our findings, and then if we all agree, we can maybe put together a policy recommendation for external players. Thank you. Okay.
Thank you, Giuseppe, really, for all. And then I call to the desk my friend Klaus Sørensen, that is the president of SIGR, because one of the activities that we have done during this month before Bari is to try and to succeed to strengthen the collaboration, please, Klaus, between the Club of Bologna and SIGR. You know that the second articles of our internal use, you can see it written, is that, just a moment, and then, okay, you have, okay, I go on. Is to collaborate with the SIGR, and also with the FAO, with UNIDO, and Accademia dei Georgofili, and with other international organizations. So we have had a call with Pedro Zazueta, that is the SIGR General Secretary, and member of the Executive Board on April. Pedro had to be here, but he has had some problem with the family, with the health of a family, and so he is not here. Klaus Sørensen, that is here, the SIGR president, was officially appointed like the representative of the SIGR within the Club of Bologna. Thank you for your collaboration, for the next collaboration. And we have discussed some topics about the strengthening, about the Club of Bologna participation to next SIGR Eurogang joint conference, which will be held in Torino next year on 24, 26 of June, and we'll be there and with our patronage, yes, and we will work together. I leave you the floor, Klaus.
But I think we put my presentation on the wrong computer.
Okay, if we want.
Yeah, I will go quickly.
Yes.
Yeah.
Okay.
Okay. Thank you, Danilo, for this presentation. Yes, and thank you for giving me the opportunity to talk a little bit about cooperation and synergy between CIDR and Club of Bologna, because I think there are some important things that we could improve our cooperation about. What is CIDR? Just to recapitulate very quickly, it's a global organization to advance science and technology in the field of agriculture and biosystems engineering. Encourage education, mobility, and of course exchange research results and technologies. And it's important that to represent the profession at a worldwide level. The organizations, we have regional societies like European Association of Agriculture Engineers, ASABE, etc. The key structure is also that we have some technical sections that deals with specific research topics. And then we have some more dynamic work group that can initiate different topics, and when these topics has been researched, etc., they can be dissolved again. But I would like to start someplace else to say why do I see that we can, especially in this point in time, we can especially cooperate in a beneficial way. Because I think we have seen yesterday and today, these new technologies we are talking about, they are different from what we have seen in the past. So there is a new technology understanding, like I could call it. This morning there was something about we have to define the context of how technology works. It's not like in the old days you improved on some mechanical item and you just put that into the machine and then the production system went on as previous. No, we have data, we have AI now that completely change how the production system works. But that also creates problems because sometimes in the literature it's called the problem of implementation. That you need to know about the domain, you need to know about, to define the context. Otherwise, these technologies will not work, and I think that is one of the main reasons why we have the technologies, but they are not being adopted. Also, we are very good at optimizing the processes, but we are not good at optimizing on the system level. And that can actually create some problems. Just quickly mention one example, precision irrigation. You can be very efficient in how you apply water. But what about the farmer? He says, okay, then I can expand my crops that uses water because now I can do it more efficient. So actually you are optimizing the process, but you are also increasing the usage of this resource that you are trying to minimize. So again, we need to look at the system. We need to work with the users. We need to combine academia and the application, the companies that work with the application of the technologies. And that's why if we look at the chain of the technology readiness level, maybe you can say CIDR is more on the fundamental of research, and the Club of Bologna works with the implementation. So, very good and distinct cooperation opportunities we have here. Some of the key collaboration opportunities, Danilo had also mentioned some of them, of course, is that we can have meetings where we discuss strategic issues of ag engineering and biosystems engineering. What are the global strategies we can align with each other? We can use each other's dissemination channels to make more, to make people aware of what is going on in our profession. And of course, that also spills into educational activities. Liaisons, we can have cooperation with FAO and UNIDO, that already mentioned. Again, promoting international cooperation. We can, membership and participation in our organizations, we can also work together there because we each have a lot of information and networking and contacts. And of course, just to mention from a historical point of view, there is a historical connection between CIDR and Club of Bologna going back to Professor Pellicci, who was also a former president of CIDR. So what are the concrete actions we can do? For example, we can have an article about this meeting that can be distributed to all CIDR members. We can cross-link Club of Bologna and CIDR websites, presentations, etc., that are being made at meetings can be shared. And of course, conference collaboration, like also mentioned that, for example, next year in Turin, we can have a theme for Club of Bologna in this conference. Webinars, arrange joint Club of Bologna and CIDR webinars, etc. And that I was talking about the membership development, identify countries where Club of Bologna could increase its membership. CIDR could assist in that. And I think we already talked about the secretariat from the two organizations. They can compile and circulate a list of prospective new members. And of course, we can encourage each members of each organization to work as ambassadors for our common profession. So, in summary, I think CIDR and the Club of Bologna can really work together to close the gap between academia and the application, the companies working with the application of the technologies. And of course, we can develop policy briefs, etc., based on that. But the key and most important is that we can create a feedback loop in our organization. So all the information from this meeting and from CIDR meetings, they are really being shared, because as it is now, sometimes you have the feeling we are in some kind of silos, and I think we can improve on that. Thank you.
Okay, I shake your hands because it's important contribution that we together can give to the development of agricultural mechanization, and also to solve some important problem for the next generation. Thank you. Thank you. So I'll return to the previous slides. Okay. And we go towards the closing session now. Program of activities. Next edition of the Club of Bologna members meeting will be held at EIMA in Bologna. Pay attention because the next edition is not end on Sunday, but on Saturday. So we'll be in Bologna on Friday, November. That means that the day before we'll stay in Bologna, and Saturday, the 14th of November. So save the date, please. About the Club of Bologna members meeting, we have, together with Professor Joseph de Bardemaker, we propose the 3 sessions. The first one is very important, really, and very of actuality, is about the mechanization for emerging countries with a focus particular on Africa. Jos, two words, please.
Yes, I think we have had a session before on this mechanization for Africa. I think we wrote a text about it that was very well used by FAO or by Joseph and Karim to bring the mechanization to the attention of FAO. I think now we should get a step further. I think we should also get industry involved because I think, as we said, maybe academia can talk about it, but industry will have to do it in developing countries. So we want to have their experience, see how their initiatives that they have already taken work. How can we get the agricultural machinery industry, but maybe we can also learn something from other industries, other technology developments that have reached the success in those countries. So this is the direction we want to go with that session.
Thank you, Jos. Thank you also to Karim and to the other components that are very involved in this topic. The second session will be about conservative soil tillage. We have to work about this topic to define, for example, also the chairman. For the third session, I hope in your proposal. So please, you have the form, okay, Carl immediately solved the problem.
Thank you, Danilo. I think it could be of interest to have a session on education. We have not had for a long time, and education in agriculture and engineering is very different in the countries, so could make sense that to exchange experience also in the discussion, education at university, on university level, you see. My proposal.
It's a fun proposal that we will discuss in the next meeting online of the managing committee, and you will be invited to this meeting to define better the proposal. Thank you for your help and your continuous support to the Club of Bologna. Other decision of the Club of Bologna, me and also Marco. Marco, if you want to reach me, please, don't leave me alone at the end, is to organize more and more managing committee meetings online. It's so simple, and we have in the spring 2026 to define definitively the program of the next meeting. 2 words about this, please. No, okay, I can continue. We want to consolidate the managing committee members group, not only during the club, but on all the year, to develop and expand our activities, including specific tasks assigned to certain managing committee members. Spiros, for example, has proposed himself to improve our website. Thank you again, Spiros. To provide updates on the organization of the next meeting in Bologna, to provide updates on the progress of work and proposal from the study groups that can be straightened a little bit, because some study group has few participants. And so if you want to give your contribution, please contact the person of reference of the study group. And also to identify potential new COB members, especially people coming from areas that are currently not well represented.
Yes, we have to, for example, for the last point, please, in few days I will upload on the club website the annual report. You can have an idea of which are the countries that in our opinion is a good idea to improve the number of members. So please, for example, taking in account this consideration of Danilo. After that, we will continue as usual our ordinary, activity. That is an activity mainly based on contact with the members, and of course to organize the next meeting, because the organization is not so easy. Is full of problems to solve and so on. So that is basically our task in near future. Okay.
Yes, and I like the suggestion of Maria Teresa Maschio, that I thank again, of increase the feminine representative inside the Club of Bologna. That is important from a lot of point of view, yeah, really. Other decision, next year we will have the 6th edition of the Pellizzi Prize. We will have 3 winners that will be called during the Club of Bologna. The terms on application is the end of May, and the topics will be defined in a management committee online in March, April. If you have some suggestion also about the topics, the suggestions are welcome. You see the list of the winners. Some of them I'm very happy are with us. One, Dana Choi, is also a member of the managing committee. Thank you, Dana. And so you see all the members. The last one, Luke Soon, Zixuan He, Xintian, then Christian Birman. And so thank you for your presence here. You are really the future of the Club of Bologna, Thank you. Please. I am running, because we are really on late. So sorry, but I have to run. Another topic is the COB website, the LinkedIn group management. The COB LinkedIn group started on 2023 and is managed by Patrizia, that we have to thank. Patrizia is not here because of a little family problem, has returned early to Rome, to his house. During the last year, several news were posted. So if you have news, about Congress, about activities that you are organizing, please send them to Patrizia. The LinkedIn group is the Club of Bologna 1. Yesterday we were 207, today we are 208 followers. So if you have time, please immediately link to LinkedIn. Please promote both the website and the LinkedIn group. Next year, the Federunacoma will overhaul the website, making more modern, easier to navigate, and also more attractive. Yes, with the help of Spiros. Thank you again. Final remarks, all the presentation.
Okay, all the presentation will be uploaded in few days, I hope, on the club website. And the novelty for this year, we try to implement this opportunity. All the club meeting was in streaming, and so we try to put also the video of the meeting during in our website. This is the most important news. Please remember that in proceeding of this year, in the top of the list of file, you can download the form just in order to suggest us to suggest any kind of new proposal subject to be discussed in future. We will take it into account during our online meeting in next spring. And very, very important, the key sentences, you know, the key sentences, download the file, compile, type the file with your sentences, and please send to me, but very important to rapporteur, session rapporteur, that we thanks for their work and next day. Okay.
So before officially closing this meeting, I would like to express my sincere gratitude to all of you for your support, suggestion, and disponibility. Thank you very much. I was really excited at the beginning of the meeting. Now I'm only tired, but it's okay. Yes, thank you for your support. To the president of Ferunacoma, to the director of Ferunacoma, and also to Fabio Ricci and Patrizia Menigucci for their support to the COB activities. To all the keynote speakers, to the session chairman rapporteurs, to the coordinators of the study groups that have participated to this COB. A really special thanks to Marco. Without Marco, a president is lost. And so, yes, he's lost. He's lost. For his friendship, we are friends. For the experience, for the incredible professionalism. Really, it's easy to do the president with the help of Marco. And closing, I declare close the meeting of the Club of Bologna, the first time in Bari, as a good experience for me. And see you next year in Bologna at EIMA 26 exhibition. Safe return home.